Okay, so last functional group. This last functional group that we're going to talk about in this particular unit is esters. And again, the esters are very much kind of related. Alcohols, well, actually, all of these things are very much related, right? If I had an aldehyde, it means that I have this carbonyl group on the end, right? And if I had a ketone, it means that I've moved the carbonyl group into the chain, right? And it's just the same with acids and esters. If I have an acid, I have the carboxyl group on the end. In other words, I've got this thing ending with an H, okay? If I have an ester, it means I have this carboxyl group in the middle of the chain. So I've taken here that C double bond O. On the end, it's an aldehyde. In the middle of the chain, it's a ketone. For a carboxylic acid, on the end with an H, the carboxyl group on the end is a carboxylic acid. And put a carbon on the end of there instead of a hydrogen, put it in the chain, it's an ester. Okay? So very much related to each other. That's why we teach them together. Remember when we made the ether, we took two alcohols and we stuck them together, pulled a water molecule out from in between? We called it a condensation reaction because we took two bigger molecules and put them together to make even a bigger molecule. That's the same maneuver here. We take the carboxylic acid and an alcohol, put them together, take out a water, and then what you've done is you've welded that group onto the end there. And I think of it in terms of mechanical terms. I've used the term welding, welding, but you know what I mean. We stick them together. So a carboxylic acid and an alcohol makes this bigger molecule, an ester, and then water happens to be the other product there. This again is called a condensation reaction because we have two bigger molecules coming together to make an even larger molecule, and a little piece was taken out. All right? We call it esterification, but it is what we call a condensation reaction. So let's do a couple of examples here. And we're actually going to learn a little bit about the naming of esters at this point at the same time. We can actually cover the two things at the same time. So I need the names of my starting molecules here. What is this stuff called? Ethanoic acid. Ethanoic acid. Ethanol, right? So we're going to take an ethanoic acid and stick it together with an ethanol. Again, we're going to be removing a water. So what catalyst works great here? Yeah, concentrated H2SO4 is our catalyst. Again, the concentrated H2SO4 is going to pull off a water molecule. I'm not sure which oxygen comes and goes. But for the sake of making the naming easier, I'm going to have us remove the H from this guy and the OH from this guy. All right? And I'll explain why in a moment. So the concentrated sulfuric acid sucks out that water molecule, H2O. Doesn't matter the order. I've only put that first so then I can now put what's left at the end. And now I've got this chunk welded to that chunk. Straightforward. So CH3, C double bond O, there's its O, and then CH2 and CH3. Okay? Now we have to name this thing. Now this particular type of thing is also named in two chunks. All right? It's kind of like the ether where we had the methoxy group or the alkoxy group, right? But it's a little different. In order to name these guys, you need to imagine that you're cutting the molecule in half, and you got to cut it in half right where that welding point took place. Okay? All right? Now, the name of this chunk. Well, we've actually seen the name of this before. CH3, don't write this down, COO minus, without an H on it. What have we called that in the past? We've encountered this in the past. We encountered it last year many times. This is an acid that has lost its H. Sorry? This is not carbonic acid. Nope. This was acetic acid, but it lost its H. That makes it acetate. Does that sound familiar? Like any acids, if you have, let's say you had carbonic acid, H2CO3, and let's say you took all of the H's off, what do we call that guy? Carbonate, right? When an acid loses its H's, it goes from ic to ate, right? Does that sound familiar? So this is acetate, but if we use our new name, what's it going to be called? Let's take this ic and let's turn it into an 8. What is that chunk going to be called? Actually, we call it ethanoate, right? So ethanoic, right? Ethanoate, okay? So this end piece is called ethanoate. Now, I'm not putting the name together because actually it comes last because it's the parent name. But I'm just naming the chunks for now. Well, we've encountered a chunk that looks like this. What's a chunk that is like a C2H6 except it's missing one H? We call that an ethyl group, right? We call it ethyl. And therefore, our name is, and because this is the parent name, this is the O8 part is really, it carries the functional group. This is called ethyl ethanoate. All right. Ethyl ethanoate. That's kind of a neat name. Let's get rid of some of this stuff, and let me just put a few more things here that are important. Okay, get out of the way. Get out of the way. Where'd you go? Oh, all right. Ethyl ethanoate. The ethyl comes from the alcohol. So the ethanol becomes ethyl. And the end part comes from the acid. So if you have ethanoic acid, it becomes ethanoate. All right? And that will always be the case when we make the ester. Now, I've got two of them that have ethyls, but they don't have to be the same. They could be whatever. Yeah, that's great. We're not going to worry about that. It says acid loses the OH. And look at this note says the acid loses the OH. I wouldn't think of it in that way because you're going to mess up your naming. I think of it that the acid loses the H. I don't care which one it does. I think scientifically they've determined that the acid loses the OH, but I'm not concerned. Okay, we have this grouping together. So let's now talk a little bit about esters themselves. So it's called an ester linkage. It's only polar. Well, it is polar. It's only London and dipole-dipole. There are no H's bonded directly to the O. So we do not have hydrogen bonding here. It's not as polar as the carboxylic acid. It becomes less polar. That means you can now add your esters into that grouping with the rest of them that are just London dipole-dipole. Next, we'll go over quickly how to name these things. We've already talked about it, but let's do a little bit of practice, and I've already given you that sheet with the carboxylic acids, right? So I'm going to switch to that page there. So, naming esters. The first part of the name is the alkyl group from the alcohol, and we just talked about that. So you go to the alcohol, and you take a look at what's in there. The second part comes from the acid, except you change it to O8, right? So we could even predict the name of the substance. So here's an example right here, right inside of our naming rules. We could predict the name of the ester just by looking at the alcohol and the acid that we're reacting. What's the name of this thing going to be? What's this ester going to be called? Ethyl, yeah, good. Ethyl, right? Propanoate. Propanoate. A terrible L. It's kind of falling over into the why? Well, it was ethanol. What do you think? It's drunk. It's a drunk L. All right. The L is drunk. Mr. Sanders is not drunk. I'm recording this. I just want to make sure. Make sure everybody understands. Okay, so if you know what alcohol you're starting with and you know the acid, you can easily get the name of it. Oh, here's another example. Name the ester formed from butanoic acid and methanol. So here's another example problem. What's its name going to be? Yeah, good stuff. Methyl, we'll give that an upstanding L. Butanoate. Butanoate. All right? Make sense? Okay. If I give you a molecule like this and you've got to name it, you've got to spot that functional group, right? You've got to see there, right there, there's that carboxyl group. That's going to tell you, oh, wait a minute, this is an ester. That means you've got to cut it in half. And you've got to cut it in half so that the carboxyl group is with the acid side and the alkyl group is with what was the alcohol side. You must cut it in between the singly bonded O and the carbon. The mistake is to cut it on this side, close to this C double bond O. That's not correct, right? Because the H used to hang off of this position. So you've got to cut this thing right there in order to get it right, okay? And I imagine, on a test, I'd even put a line there so that it would help me. What's my front name? This is a butyl. And what's the back name? Propanoate. Very good. Propanoate. All right? So if you cut the molecule at the right spot, you're going to get it right. Now, you might ask, what if there's branches off of all these things? I'm not going to give you ones with branches. I'm just giving you the basics of what an ester is, and we're not going to worry about that. Okay? Let's do the next one here. Okay. So, where am I cutting this guy? Where am I going to cut this guy? Yep, just describe it to me. Between the ethyl, O and the ethyl. That's a perfect description. Right there. So what's the first name? Ethyl. And then we had a name for this the other day. I told it to you. It was a special guy. When we have a benzene ring stuck to that carboxyl group, what was that acid called? It was called benzoic acid. So what's this going to be when it loses the H? Benzoate. 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 Ethyl benzoate. All right? All right? Okay. And we've got one here that is draw. Draw pentyl methanoate. Again, I always go to the end of the name, right? The end of the name tells you where to start. Methanoate means we're starting with methanoic or acid, right? That has lost its H. How many carbons in methanoic acid? 1, which means I've got C, I've got double bond O, I've got the O, and then I've got the H that goes off the end of it, right? To complete this, I need another H on the back side because it has no carbons on it, right? So I need 1, 2, 3, 4. There's methanoic acid. And now I need a pentyl. 5. 1, 2, 3, 4, 5. And I load it with H's. H2, 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 H2. See, Bailey, if you just squeeze them in like that, you draw your pictures much quicker. H3, H3. What alcohol and what carboxylic acid would I have to mix? Yep. Yeah, so I would have to have methanoic acid plus, what was that last one? Pentanol. And actually, it doesn't tell me, all right, what carbon it's on. So if we're going to assume this one, I guess it's 1 pentanol, right? Because if it was another pentanol down the chain, then I'd have it stuck to it in the middle of the chain. So technically, I would need 1 pentanol. Pentanol. All right? And that would make it. All right, that's perfect.